This section 2.6, this video is for December 8th and 9th, Tuesday and Wednesday, December 8th and 9th, section 2.6. We're going to talk about adding and subtracting functions, multiplying and dividing, and composition of functions, and I think that's it, and domain of functions. Okay, so let's start off with, number 1, f of x is equal to 2x plus 1. And first off, you know that this is a function for two reasons. One, this is a line. The degree is 1. So you know it's a function because it's a line, because the degree is 1, and also because, very simply, because I tell you it's a function by writing f of x. The second function I'm going to give you is g of x is equal to x squared plus 3x minus 1. This is a function. It is quadratic function. It's a squaring function, which when you graph it, you get a parabola. And it's a function because I'm telling you it's a function. And when you graph it, you get a parabola that does pass the vertical line test. Okay, so let's talk about the domain of this function here. It's a line, so the domain goes from negative infinity to infinity. This is a parabola, and a parabola, remember what that looks like. Of course, that's not what this one looks like, but you know what a parabola looks like. The domain goes from negative infinity to infinity. Okay, so just a refresher as to what domain is. Remember, it's a set of all x values. Okay, so part A, I want you to find f plus g of x. Now, I know that you did this last year in Algebra 2, but it may be written differently than what you wrote it last year. Last year, you probably did something like this, f of x plus g of x. So it's the same thing, it's just a different way of expressing it. And all that you're going to do is you're going to take your f function, 2x plus 1, and you're going to add your g function, x squared plus 3x minus 1. Okay, so you're just going to add your like terms. There isn't anything to add to the x squared, but you can take the 2x and the 3x and combine those, and you get 5x. 1 plus negative 1, that's 0. So you get this answer. You don't solve it. There's nothing to solve. All you're doing is adding the two functions together. You're done. Okay, now part B, let's subtract the two functions. Okay, so you're going to take those two functions, 2x plus 1, and this time you're going to subtract. Now notice I'm going to use parentheses here. That's really important because of the subtraction. Don't mess it up because you're not using parentheses. Now, I would advise, my box got too big there. I would advise that you distribute the minus sign through. So what I mean by that is do the algebra doorbell. Ding, dong, 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 and change all of the signs in that second parentheses. So now what you have is addition, so now you don't need the parentheses anymore. 2x plus 1 plus negative x squared plus a negative 3x plus 1. And then you add your like terms. There's nothing to add to the negative x squared, so you start with that one because it's the biggest exponent. 2x plus negative 3x is negative x, and 1 plus 1 is 2. So your answer is negative x squared plus negative x plus 2. And then you're done. Don't do anything else to it. You are done. Okay, now C. What if you have fg of x? There's no sign in between the f and the g, so that means you multiply the two things together. So you're going to take your f function, 2x plus 1, and you're going to multiply it by your g function, x squared plus 3x minus 1. So you multiply, which means you distribute. Now you can't use the FOIL method on this, which I despise anyway, but even if it were a 2 by 2, if you had two terms and two terms, you could use the FOIL method, but I don't like the FOIL method because it doesn't work on big ones like this. So just distribute. Distribute from the 2x, and then distribute from the 1. So I'm out of airspace, so I'm going to submarine it. So you're just multiplying here. 2x times x squared, that's 2x cubed. 2x times 3x, that's 6x squared. 2x times negative 1 is negative 2x. Now from the submarine, 1 times x squared is x squared, so you just line up your like terms. 1 times 3x is 3x. And 1 times negative 1 is negative 1. And then you add your like terms. So you get 2x cubed plus 7x squared plus x minus 1. And then you're done with that. Okay, now D, so we've done addition, we've done subtraction, we've done multiplication, so guess what's next? And that is division. Now I'm going to divide this in a very specific order because I want to be able to do something. Okay, so I'm going to go with G, and this is the only time you'll see me use slanted fraction bars. Divide it by f. That's slanted fraction bar means divided by. A fraction bar of any sort means division. So what we're going to do is we're going to take the g function and we're going to divide by the f function. So you're going to take the g function, x squared plus 3x minus 1, and we're going to divide by the f function, which is 2x plus 1. Okay, nothing simplifies there. It doesn't factor, so we can't factor it. You can't simplify that. Now, what you are going to be asked to do, because it's a fraction, you have to be concerned about what the domain is. You learned about domain and functions in my absence while I was gone. There are two situations that you need to be concerned about with domain. And one of them is when there's a fraction, because you can't have 0 in the denominator of a fraction ever, because that makes the fraction be undefined. So you have to be careful that this denominator never becomes 0. So you're going to take 2x plus 1, and you're going to figure out what makes that be 0. So sometimes you can just see it. Other times, if you can't see it, then write the equation out and solve that. So what makes it be 0? We're going to solve that by subtracting 1 from both sides. 2x equals negative 1. X equals negative 1/2. So that's what x cannot be. So what can x be? Okay, so if x cannot be negative 1/2, it can be everything else but that number. It can be everything from negative infinity to negative 1/2, and then from everything from negative 1/2 to a positive infinity. So it can go from negative infinity to negative 1/2, can't be negative 1/2, in union with from negative 1/2 to infinity. So that's the domain. Now, I said that there are two situations where you have to be concerned about the domain. One of them is when there's a fraction and you have to be concerned about the denominator. The other is if there's a radical. Like, let's say that you had the square root of 3x plus 7. The thing you have to worry about with a radical is if there's a negative underneath the square root or an even root. So you have to restrict what's under there to make sure it's positive or 0. So you take what's underneath there and you set it greater than or equal to 0. And then you solve that. So 3x is greater than or equal to negative 7. X is greater than or equal to negative 7/3. So the interval for something like that, you would start it at negative 7/3, and it goes to a positive infinity. So if you have a radical, you set the stuff that's on the inside greater than or equal to 0, and then you solve it and write the interval. Okay, so you can add functions, subtract functions, multiply functions, and then divide functions. And when you're dividing functions, that's when you need to be careful and look at the domain. Okay, so let's do another one, number 2. I'm not going to do all of it though. Let's say that we have f of x is equal to the square root of x, and g of x is equal to the square root of 4 minus x squared. Okay, so let's first talk about the domains of those functions. Okay, so we just talked about radicals, and we can't have negative numbers underneath a radical. So if you look at this first function, x has got to be greater than or equal to 0. So that means that this interval has got to start with 0 and go to positive infinity. Okay, now let's take a look at this one. 4 minus x squared. Okay, so let's think about that one. 4 minus x squared has got to be greater than or equal to 0. Okay, now we have to think about how we solve this. This was in last chapter. To solve this, we have to find our critical points. So we're going to pretend it's an equation for the time being. And we're going to solve that equation. So I think I would subtract 4. And then divide by negative 1. And then take the square root of both sides. So the absolute value of x is equal to 2. So x is equal to both positive and negative 2. So I know I've got critical points at negative 2 and positive 2. So the question is, where is this graph greater than 0? Okay, so let's go to our calculator. I don't think I've got mine turned on yet. And go to y equals and type in 4 minus x squared. And hit graph. So where is the graph greater than 0? Where is it above the x-axis? It's above the x-axis in between negative 2 and 2. So in between negative 2 and 2. So right in here, okay, I'm going to draw that graph. So in between negative 2 and 2. So that's where it's positive. So that's my domain, in between negative 2 and 2. And it can be negative 2 and it can be positive 2, because that's what makes it be 0. Okay, so I was just finding the domain on that. Okay, now part A. Find f divided by g of x. Notice I wrote that a little bit differently. Okay, so take the f function, which is the square root of x, and then take the g function and divide it. So square root of 4 minus x squared. Okay, now we've got to do the intersection of both of those domains. Okay, so where do they overlap? Okay, so to do that, it would be wise of you to draw, oh, that was a weird looking straight line. Draw a number line and graph this domain. So here's 0, and I'm going to put a bracket on there and shade to the right. And then at -2, and I'm just going to go above here, and at +2, and it's got a bracket on it. Okay, and then the shading is in between there. Okay, now where do they intersect? Where do they overlap? Okay, they overlap starting at 0 and over here to 2. Okay, but can it be 2? What happens if you plug 2 in here? 2 squared is 4. 4 minus 4 is 0. The square root of 0 is 0. So now all of a sudden you've got 0 in the denominator. Can't have that. So the domain, okay, so we're starting at 0 and it goes to 2, but it can't be 2. Can it be 0? 4 minus 0 is 0. The square root of 0 is 0. On the top, the square root of 0 is 0. Yeah, that's, oh, wait a minute. 4 minus 0 is 4. The square root of 4 is 2. Okay, so that's fine. Square root of 0 on the top, that's 0. That's fine. So it can be 0, but it can't be 2. Even though there was a bracket on the 2 here because it made the denominator be 0. Okay, so there's that one. Now let's go the other way. Let's do g divided by f. So take the g function and divide it by the f function. Okay, we can't do anything else with that, but let's talk about the domain. Okay, so we have the same number line situation. Let me draw it again though so I can highlight again. Got a bracket, shading. Okay, then -2, 2, bracket, bracket, shading. Okay, now I need the overlap. Okay, so from 0 to 2, okay, so that's where the overlap is. Can it be 0? If you plug in 0 here, the square root of 0 is 0. That's making that denominator be 0. So I can't have 0. Can it be 2? Square root of 2 is 2. That's fine. 4 minus 2 squared, that's 0. The square root of 0, that's 0. That's fine. So it can be 2, but it can't be 0. And there you go. Okay, so that's how you deal with the radicals. You have to be a little bit more careful on that. Okay, let's see. The next thing I want to talk to you about is in your homework, you're going to see problems like this. Let's see, this is number 3. Let's say that you have f of x is equal to x plus 4, and g of x is equal to x squared minus 3x plus 1. And you're asked to find part A, f plus g of 7. Okay, you can do this the hard way or you can do this the easy way. I personally prefer the easy way. Some people are going to want to take the f function and add it to the g function and then plug in 7. I personally don't want to do that. I would prefer, myself, to plug 7 into the f function, and then plug 7 into the g function, and then add. So, like this. Plug 7 into the f function. 7 plus 4 is 11. Now plug 7 into the g function. 7 squared is 49. 3 times 7 is 21, plus 1. 49 minus 21, you're welcome to use a calculator, plus 1. 49 minus 21, okay, that's 8. 28 plus 1 is 29. Okay, now add those together. 29 plus 11, 30, 40. So the answer is 40. Okay, and then let's see, part B. Find f g of 0. Okay, so again, I don't want to multiply those two functions together and then plug in 0. I just want to plug in 0 to the f function, plug 0 into the g function, and then multiply them. So plug 0 into the f function, 0 plus 4 is 4. Plug 0 into the g function, 0 squared is 0, minus 0, plus 1. It's 4. Easy peasy. Okay, next thing we need to talk about is called composition of functions. Oh, actually, I don't want to do that just yet. Just a second. Okay, next problem. On this problem, we have some fractions here, so I might have to do a little bit of fraction review. F plus g of x. Okay, so f of x is 1 over 2x. G of x is 1 over x minus 2. So we're going to add those two functions together. So we're going to do 1 over 2x plus 1 over x minus 2. In order to add or subtract fractions, you have to have a common denominator. And to find the common denominator, everything has to be represented. So you have to take the 2x, because that's from the first denominator, and that has to be part of the common denominator. And then you have to take the x minus 2. That has to be part of your common denominator. Okay, so now the numerators, what you do to the denominator, you also have to do to the numerators. So from the 2x to the x minus 2, you have to multiply it by x minus 2. So you have to multiply the numerator by x minus 2. So that numerator becomes x minus 2. From x minus 2 to 2x, x minus 2, you have to multiply by 2x. So the numerator, you have to multiply it by 2x. You can't clear the fractions when it's just an expression. So you have to find your common denominator and then add your numerators. X plus 2x is 3x over 2x, x minus 2. And then you're done. Don't do anything else to it. When you're multiplying fractions, 1 over 2x times 1 over x minus 2, you're going to multiply the numerators and multiply the denominators. So 1 times 1, that's 1. Don't cross multiply, just multiply the numerators, and then you multiply the denominators. 2x times x minus 2. There's no need to multiply that all the way out. Just leave it as 2x, x minus 2. Okay, when you're dividing fractions, you have 1 over 2x let me rewrite that. 1 over 2x divided by 1 over x minus 2. You change the division to multiplication, and you flip the one that's on the right side. And then you multiply straight across. Don't cross multiply. Multiply your numerators and multiply your denominators. Now let's talk about domain. The domain of f of x cannot be 0. It can be anything but 0. So we have to look at the originals first. It can be anything but 0. So it goes from negative infinity to 0 and union with from 0 to infinity. And x minus 2, it can be anything but 2. Sometimes it's easier to look at it on a number line. That's why I'm doing that. It can be anything but 2. So it goes from negative infinity to 2 and union with from 2 to infinity. Okay, now to get the division domain, we have to look at the intersection of those two domains. So let's graph that on one number line. Okay, so the first one, it can't be 0. Okay, so I'm going to graph that, can't be 0. And then the second one, it can't be 2. So here's 2, can't be that number. So where do they overlap? What two things can it not be? It can't be 0 and it can't be 2. So it's going to go, can't be 0 and it can't be 2. It's going to go from negative infinity to 0, from 0 to 2, and from 2 to infinity. So from negative infinity to 0, from 0 to 2, and from 2 to infinity. That's your new domain. Okay, then D kind of combines some things here. You could, if you wanted to, take the f function minus the g function and then plug in 3. I wouldn't do that myself. I would plug in 3. So 1 over 2 times 3 is 6. So 1 over 6. Oh, that's wrong, my stylus. Minus, okay, plug in 3. 1 over 3 minus 2. 3 minus 2 is 1. So 1 over 1, that's 1. So you've got 1/6 minus 1. You can probably do that really easily without a calculator. 1/6 minus 1 is negative 5/6. And then you're done. Okay, so the last topic that we need to talk about that I was going to do, and then I changed my mind, is composition of functions. And again, you did this last year. It might be a little bit different. But I might write it a little bit differently, but it's the same concept. The notation that we use is an open circle, and I call it FOG, or if it's G open circle F, it's GOF, or F open circle F, it's FOF, or G open circle G, it's GOG. You get the idea. Okay, so example number 5. If f of x is equal to x plus 2, and g of x is equal to 4 minus x squared, find FOG of x. Okay, now when I see that notation, I immediately rewrite it as f of g of x, just because I think it's easier to look at that way. It's kind of like turning your fog lamps on your car. It's easier to see. Okay, so this is what you should do. First, find what's on the inside. what's g of x? Well, g of x is 4 minus x squared. So cross that out and put 4 minus x squared inside there. Now you're going to find f of 4 minus x squared. So you're going to take that 4 minus x squared and plug it into the f function wherever you see x. So it's 4 minus x squared plus 2. And that gives you negative x squared plus 6. Now let's talk about domain. The domain of the original f of x function is negative infinity to infinity because it's a line. Of the original g function is negative infinity to infinity because it's a parabola. There's not a fraction, there's not a radical, you don't have to worry about it. So for a, the Fogg function, the domain is also negative infinity to infinity because there's not a fraction and there's not a radical, so you don't need to worry about it. And the intersection of these two is also negative infinity to infinity. Okay, B. Let's find Goff. Okay, so we're just going the other way now. So rewrite it immediately as g of f of x. So we're going to find f of x first. F of x is x plus 2. Now find g of x plus 2. So you're going to take the x plus 2 and plug it in for x. Now because there's subtraction there and a square, make sure you use parentheses. So 4 minus, okay, we have to square that thing. Be careful. It's x squared plus 4x plus 4. Notice I kept the parentheses there because my subtraction is still there. So it's 4 minus x squared minus 4x minus 4. The 4's drop out, so I get negative x squared minus 4x. My original domain for f of x was negative infinity to infinity. My original domain for g of x was negative infinity to infinity. My domain for the composition is the intersection of those two things. I don't have a fraction. I don't have a radical. I don't have a problem. The domain is negative infinity to infinity. Okay, let's do another example of a composition, and then I think we can call it good. Number 6, f of x is equal to the square root of x plus 4, and g of x is equal to x squared. Okay, let's talk about domain. The domain of the square root of x plus 4, okay, we have a radical, so we need to be concerned. We cannot have negative numbers underneath the square root. So that means that x plus 4 has got to be greater than or equal to 0. So x has got to be greater than or equal to negative 4. So the domain is from negative 4 to infinity. Versus the g of x, there's no fraction, there's no radical. So that domain is from negative infinity to infinity. Okay, now part A. Find Fogg. Okay, so replace that with f of g of x. Immediately rewrite it. Find g of x. G of x is x squared. Plug x squared into the f function. So plug it in right there. And you get the square root of x squared plus 4. A lot of people think that they can take the square root of x squared and take the square root of 4, but you can't do that because that plus sign is there. That's your answer. It's the square root of x squared plus 4. But let's talk about the domain. we have to look at the intersection of these two things. So let's graph it. Negative infinity to infinity is the whole line. But from -4 to infinity is just this portion. So the domain of this is -4 to infinity. Okay, then B. Find Goff. Oops. I don't know, something's going on with my stylus here. Okay, so immediately replace that with G of f of x. Okay, so find f of x. F of x is the square root of x plus 4. And then plug that into the g function. So you get this. So you're replacing the x with the square root of x plus 4. You gotta square that. And that gives you x plus 4. Now you would think that your domain would be negative infinity to infinity because that's just a line. But no, you have to look at the intersection. And that intersection is also -4 to infinity. You have to look at the intersection of the two originals. And there's no fraction there, so you don't have to be concerned anymore. You don't have to restrict it any more than that. There's no radical, so you don't have to be concerned about that. So you are good to go on that. Okay, I think that concludes what we're doing. Please make sure you ask questions if you don't understand something. Just let me know. Okay, have a great night.